Our facial performance workflow begins here in faceware Studio. With faceware Studio, you can bring in a video source, track the face of the performer in that video source, and ultimately stream the resulting tracking data out to Unreal Engine for use with MetaHumans. Faceware Studio features two distinct input types, live and media, as well as two different tracking models, stationary camera and professional head cam. In this module, we'll explore these different settings, as well as others to configure a video source, begin tracking, and ultimately stream the resulting tracking data out for use by Unreal Engine. Let's begin with the live input type. The live input type allows us to choose a camera connected to the computer running faceware Studio as a video source for tracking. In this case, I'll use the Select a Camera dropdown to choose a compatible USB connected camera. Once that camera has been selected and activated, the video is available here in the viewport so that we can see the video source as it's streaming live, as well as an indication of the current resolution, the tracking frames per second, the video frames per second, and whether or not it's calibrated. The video source is approximately 30 frames per second, and we're tracking it at real time. However, the resolution is defaulted to a low optimized value of 640 by 480. Faceware Studio tends to default to this optimized setting in order to protect underpowered computers from being bogged down by high-resolution video sources. My video source is a 1920 by 1080 HD camera, so I'm going to choose that from my resolution options here, and also deactivate the Optimize for Real-Time, as this option is still limiting my resolution to the 640 by 360. With Optimize deactivated, now we can see that the resolution is a full 1920 by 1080, and we're tracking at the full frame rate of the camera. Note that if I was interested in throttling the frame rate, I could use the Framerate Control. The Framerate Control is set at the maximum 60 frames per second. This isn't affecting my frame rate at the moment because the camera is only providing about 30 frames per second. If I wanted to throttle the frame rate down to something lower, I can choose this drop-down control, perhaps choose the option of 10 frames per second. We'll again deactivate Optimize for Real-Time. And now you can see that we're getting our full resolution 1920 by 1080 at a throttled approximately 10 frames per second. I'm going to keep the highest fidelity I can with this live camera, so I'll reset my frame rate to 60 to essentially run with an unconstrained frame rate, and again, deactivate the Optimize for Real-Time so that I get my full resolution. It should be noted that generally, you can see fidelity improvements in tracking, moving from standard definition 640 by 480 up to high definition resolutions such as 1280 by 720 and 1920 by 1080. Resolutions above 1920 by 1080 begin to have diminishing returns in terms of fidelity. So there is not a whole lot of fidelity to be gained by increasing resolution beyond standard HD to things like Ultra HD or 8K. At the moment, we're not calibrated, and therefore we're not generating any tracking data. Our tracking indicators are dormant, and our 3D proxy model isn't moving. In order to initiate tracking, we first need to calibrate a neutral pose from our video source. In this case, I'll need to look at the camera with a relaxed face to calibrate my neutral pose. I'm also wearing glasses at the moment, which really isn't conducive to facial tracking, so I'll take these off, look into the camera with a relaxed face, and use the Calibrate Neutral Pose button in order to calibrate a relaxed starting point. Once I've clicked this button, I've calibrated my neutral pose, and you can see that our proxy model is responding to my motion in the video source, and tracking data is being generated by these indicators. Nice. Now this proxy model is not a MetaHuman, and so the results that we're seeing here are not necessarily indicative of what we would see with a MetaHuman model. In later modules, we'll get into how we would evaluate a MetaHuman performance against the actual data that's being streamed and tune our results accordingly. But for now, it's good that we've got our tracking data working and the results look reasonably good. So all of this has been done with a stationary camera. This camera is sitting still on my desk, and it is a live video source. So let's look at our alternatives. A media source with a head-mounted camera. So I'll choose media here in our input type, and then choose a media source using the Select Media button. There are two options here. A video file, this would be such as an MP4 video or a QuickTime movie, or image sequence, where we have a folder full of individual image files per frame. In this example, I'm just going to choose a video file. In the sample project provided with this class, there is a movies folder in the content directory of the project. And this movies folder contains a video, Hungry Purple Dinosaur. We'll use this video as our sample. Selecting it from our File Open dialog box and clicking Open brings that video source into faceware Studio. Now this video source was recorded using a head-mounted camera. So the position of our performer's face stays stationary throughout the performance, even though her head is moving, as we can see by motion in the background. However, while this gives us a better view of the performer's face and fills out the frame, the orientation of this video is conducive to tracking, as the face is not vertical in our viewport. We have image rotation as well as image flipping tools here that allow us to adjust the orientation of the video in our viewport for tracking. There are controls here to flip horizontal for the video source, as well as flip vertical. And finally, image rotation. I'm going to rotate this image by 90 degrees to bring our performer's face vertical in the viewport. It is important to note that the flip controls are relative to the video source, not what is currently in the viewport. So with this video rotated 90 degrees, the flip horizontal control might be a little counterintuitive because it will flip the video source horizontally. Remember, the source has been rotated 90 degrees, so this is the left and the bottom of the video is the right. If I choose to flip horizontally, it'll flip along that axis. Restore that. So now that we have our video oriented correctly, we'll also want to make sure we select the appropriate tracking model. This camera is not a stationary camera on a desk or a tripod, but instead it's on a head-mounted camera system. So we'll choose from the tracking model options, Professional Headcam. With Professional Headcam chosen, we can also double check that we're getting the appropriate frame rate and resolution. Let's go ahead and choose the full resolution of this video clip. We'll deactivate Optimize for Real Time and get our native 720 by 1280 resolution for this video. The source file is a 60 frames per second video file, and we are playing that back at full frame rate and tracking at that full frame rate as well. Finally, we'll need to isolate a neutral pose from this performer. Calibrate to that neutral pose so that we can begin tracking. I pause and scrub in the timeline here to select a frame that would be suitable as a neutral pose. In this case, towards the end of the clip, we get a good relaxed face, and we'll use that to calibrate our neutral pose. Now that our neutral pose is calibrated, as we play this clip, we're now generating tracking data and seeing it reflected on our 3D proxy model. Finally, now that we have our video source selected, it's oriented correctly, our tracking model is selected, and tracking data is being generated, we're ready to stream this data out so that Unreal Engine could receive it for use with MetaHumans. Currently, our stream indicator is gray, indicating that data is not being streamed out of faceware Studio. We'll go to the streaming panel in order to configure that streaming. By default, the data is going to be streamed out of Internet Protocol port number 802. you can use this port control to adjust which port the data will be streamed from if you're already using port 802 on your computer or network with some other software. In this example, we'll leave the port set to 802. For use with MetaHumans, it's important to change our control schema for streaming data to standard. Finally, we have some options here in terms of which facial groups to be streamed, as well as whether we're streaming UVs and our precision in our tracking values. For now, I'll go ahead and set all facial groups to be streamed. UV position streaming is not applicable to MetaHuman performances, and our control value precision of 4 decimal places is perfectly fine for our needs. With all of our streaming values configured, we're ready to stream to the client. Simply activate this control here, and now our indicator is indicating that data is streaming. With our video source now fully configured, being tracked, and data being streamed, we can now move on to our next module, where we'll configure Unreal Engine to use this tracking data on a MetaHuman.